So going forward, what are the tools we need in the first place in order to implement our thread-safe and highly concurrent CRUD operations? So the tools that we need is, first of all, we need to know how to work with read-write logs and not simple mutex. So we would need pthread rwlog_t type of logs, and we don't need simple mutexes. That's the first thing. Second thing, we need a reference count object. Now, what is reference count object? That we will going to discuss in detail. So as an example, let's see what are the changes that we need to make in our linked list in order to implement thread-safe and highly concurrent CRUD operations on the linked list. So first of all, we have a data structure which represents a linked list itself. So we need to have a member which is nothing but a pthread read-write log. And this read-write log is a log for the entire linked list. Then this data structure represents exactly one node of a linked list. That is, this is the data structure which represents a student object which is stored in exactly one node of the linked list. So every node of the linked list would need a separate read-write log and a reference count object. So every data structures that you have in your applications need to have the following read-write log and reference count. Instead of linked list, had you have a data structure, let's say tree, then at the tree level you need to have one read-write log, and every node of the tree you need to have one read-write log and a reference count object. All right. So in order to implement highly concurrent thread-safe CRUD operations on our data structures, we need a read-write log at a container level. Here container level means at a linked list level or at a tree level. All right. All the data structures such as linked list, trees, which is nothing but a collection of nodes, are referred to as container data structures. And you need a read-write log per container element level. That is, at every node of the linked list you need to have one read-write log, or at every node of the tree data structure you need to have a read-write log. So a node of a linked list or a tree is referred to as container element. And we need a reference count object per container element. All right, so here we have a reference count object per container element. And we will see that how this reference count object helps to prevent premature deletion of an object. Well, now what is premature deletion of an object? We have already discussed that if the thread T1 is performing read or write operation on an object, let's say O, then any other thread in the system, if perform free operation on this object O, then this free is referred to as premature deletion of an object. The thread T2 must not free the object memory as long as there is some thread T1 who is busy using that object. All right. So we will see that how reference count object will help us to resolve or to address this problem. So before going forward, we need to discuss how to implement reference count data structure and how to make use of it. So couple of next 2-3 lecture videos are dedicated on how to implement reference count object. All right. And then we will resume our discussion on implementation of our CRUD operations.